My name is Tara Hobbs, and I am a recent graduate from the University of Northern Colorado. Thank you for stopping by to view my project, Bats and Rats: Evolutionary Implications of Hind Limb Development. Through evolutionary time, bats show great variations in phenotypic expression in both living and extinct species. These various expressions allow for varying movements, abilities as well. For instance, microbats are better suited and more capable of maneuvering their limbs in a walking fashion, whereas the megabats' limb movements are more so aligned with the motions of climbing. Through assessments of musculoskeletal data, it is hypothesized that megabats evolved from a later primate ancestor, whereas microbats evolved from an insectivorous terrestrial mammal such as a shrew. My hypotheses are that the relative growth of the femur and tibia will occur at the same rates within bats and within mice, and that the growth rates of the hind limb will differ between mice and bats due to different modes of locomotion. The bat model that I used for my research consisted entirely of seabush short-tailed bats, which are a microbat that persist mainly on small fruits. The specimen were all cleared and stained using Alcyon blue, which denotes the cartilage, and alizarin red, which stains the bone. These animals were previously stained by a graduate student at a previous time. The morphological measurements were taken as the greatest length of the femur, tibia, and skull using an Olympus microscope equipped with an ocular ruler, and the data on the terrestrial ancestor was collected from a mouse model found in literature. A regression analysis was completed with the data collected to determine trends and relationships. Figure 1 shows the relationship between the length of leg elements in relation to the skull length. In this figure, both the femur and the tibia show positive relationships in relation to the skull, with R-squared values of 0.86 and 0.87 respectively. Figure 2 draws the same comparisons between the femur and tibia in relation to the skull of the mouse model that was used. Similar to Figure 1, there is a positive relationship here with the R-squared values being 0.97 and 0.99 respectively. Figure 3 references the bat model and defines the relationship between the total tibia length and the total femur length, which is positive and has an R-squared value of 0.97. Figure 4 shows the same tibia versus femur length in the rodent model and exhibits a negative regression of allometric growth rate. Figure 5 and 6 show the specimen that were utilized from the literature to measure relationships in the rodent model. There are full body images here as well as a more detailed image of only the hind limbs that were being used for this experiment. Figure 7 includes 3 of the Carolia perspicillata individuals that were used to complete my project. These 3 specimens were representative of various developmental stages that the measurements were taken at, the left being the youngest and the right being the oldest. Carolia perspicillata showed equal slopes for both the femur and tibia growth, indicating that the hind limb grows at similar speeds of development. The femur, however, does outpace the tibia in the bat species. On the other hand, the tibia and femur in the mouse model share the same slope, but the tibia outpaces the femur, supporting hypothesis 2. Additionally, the regression between tibia and femur lengths show that the Carolia perspicillata there is a positive allometric growth rate, and in the mouse model had a negative allometric growth rate, which is testing hypothesis 1. In conclusion, my data supports the idea that the ontogeny of the hind limb in bats has shifted away from an ancestral terrestrial mammal due to various selective pressures involved with the evolution of flight and no longer needing certain torsion elements involved with terrestrial movement. Thank you.